Hi guys! So for this video, ang pag-uusapan natin is the last example related to the design of tension members. So channel ang i-discuss natin ngayon. Basahin ko lang yung problem, no? So for this example, select a 4.5 meter long C-section that will carry the service dead load of 600 kN and a live load of 150 kN. The member is made of ASTM A572 grade 42 steel. Yung Fy niya is 290 megapascal and yung Fu niya is 414 megapascal, and its end connections as shown in this figure uses M18 bolts. S is equal to 85 millimeters. Letter A, design the member using LRFD. And letter B, design the member using ASD. For solution, uunahin ko muna yung LRFD guys. So, ang una nating gagawin is hahanapin natin yung value ng PU. Okay? So, ito nga, dalawa lang naman yung equations natin to solve for PU. 1.4 dead load and 1.2 dead load plus 1.6 live load. Ang sagot natin dyan, syempre, just choose the larger value. Ang mahahanap mo is 960 kilonewtons, di ba? Kasi between the two, siya yung mas malaki. So therefore, ito yung magiging design load natin, 960 kilonewtons. So of course, yung tatlong criteria natin, determine the value of R min. Yung length is 4.5 meter divided by 300. So that is 0.015 meter or 15 mm. Tapos, yung value ng AG, remember na yung reduction factor natin ay 0.90. So, therefore, AG is equal to 960 times 10 cube divided by 0.9 ng 290, which is 3,678.16 square millimeters. And lastly, compute the value of the minimum net area, which is ang ating reduction factor ay 0.75. So therefore, ang ating AE min naman ay 3,091.71 square millimeters. Ngayon guys, ang concern natin dito is C-section. Walang sinabi kung ano yung minimum depth. Basta kung babasahin natin ng maigi yung problem, select a 4.5 meter long C-section. So therefore, lahat ng C-sections i-consider natin. So kung meron tayong Appendix A, which includes the properties of C, ito lang siya, no? Ito siya. This is for C sections. Lahat yan. Pero, hindi ito naka-arrange based on, hindi ito naka-arrange based sa kanilang area, kundi naka-arrange ito based sa kanilang depth. Halimbawa, yung una is C380, C310, C250. Luckily, meron ako ditong pre-provide na Appendix B, and yung laman ng Appendix B is yung arrangement ng section from largest to smallest regardless sa kanilang pangalan. Okay? So for instance, ito yung C-shape natin. Ang pinakamalaking C-shape is C380 by 74. Sumunod, C380 by 60, C380 by 50.4, so on so forth. So, naka-arrange na to, itong table B5, naka-arrange siya based sa area niya, regardless na kung ano yung depth. So, back to the PowerPoint tayo. So, ang note natin, kailangan yung minimum net area is 15 mm and yung minimum minimum radius of gyration is 15 mm and the minimum gross area is 3678.16. So, kung babasahin natin to, from table B6, tama ba? B6 ba siya? Check ko lang B5 pala, paki-correction na lang ako. From table B5 of Appendix B, the 5 most economical C-sections are C230 by 13, C250 by 30, C10 by 20, C330 by 30.8, C250 by 37, and C310 by 37. So, check nga natin yun, no? Balikan mo na yung area natin. Net area is 3678. 0.16. Kung titingnan nyo dito sa table, dito siya magsisimula. 3,550, hindi pa siya pwede. Pero ang 3,790, pwede na siya. So, magsisimula sa C230 by 30, di ba? So, dun muna tayo sa C230 by 30, then C250 by 30. So, pataas na lang yan, di ba? Itong limang to, pataas na lang yan. Okay, so anyway, ito yung gross area niya. Now, dahil may table na tayo, itong TW, itong X bar, and itong RY, hahanapin nyo na lang naman to guys doon sa Appendix A, okay? So, sa Appendix A lang naman to lahat. Luckily, lahat naman sila class ay 16mm, ay 15mm above. So, therefore, yung radius of gyration niya ay safe. So, pwede na natin i-check lahat. So, determine the effective net area of each section. So, then check if it exceeds AE minimum. So, i-flash ko na nga lang to. Note that for M18 bolts, yung diameter ng butas ay 20mm. And yun na nga, note that all sections have RY above the minimum. So, the trial and error starts in the first section. So, yung una is C230 by 30. So, wait lang. Discuss ko lang kung paano na-compute yung net area. Yung butas class ay nasa web, di ba? So, dalawang butas siya. Kung titingnan nyo, nasa web siya. So, therefore, for C230 by 30, yung thickness ng web ay 11.4. Dahil yung diameter ng butas ay 20mm, kaya 3,790 minus 20 times 11.4 times 2, which is 3,334. Worth it pa naman hanapin yung U kasi 3,091.71 naman yung ating AE minimum. So, solve for U kapag channel, only case 2 lang ang i-consider natin. So, kasi yun lang naman yung nakakasakop sa mga channel sections. So, U is equal to 1 minus X bar over L. So, that is 0.9121. Ang sagot natin is, yun na nga, AE is equal to 3,334 times 0.9129. So, that is 3,043.75 square millimeter. And that is less than the minimum net area, kaya hindi pa siya safe. So, all you need to do is to try the next section. Kasi nga, di ba, if the first section fails, then proceed to the larger section. So, try C250 by 30 or C10 by 20. So, yung net area niya, ito siya, 3,790 minus 2 times 20 times 9.63. Ito yung thickness ng web niya, di ba? 9.63. So, therefore, that is 3,404.8 millimeter square. Solve for the value of U. So, only case 2 of table 3.3 here is applicable. So, U is equal to 1 minus X bar over L. 1 minus 15.4 over 2 times 85. So, that is 0.9094. Pag kinompute natin yung AE, so that is A and U, 3,404.8 times 4.9094. So, that is 3,096.33 and that is above the minimum effective net area. So, therefore, that is good. The most economical C-section na pwede natin gamitin ay C250 by 30. So, ito na ang gagamitin natin, di ba? Kasi kung i-check mo, yung minimum is 3,091.79. O, swertehan, 3,096, 5mm lang siya, but still, that is greater than. So, therefore, it is confident naman sa inyo na safe na siya. So, ito yung LRFD design. However, since hindi lang naman LRFD ang gagamitin natin, this time ASD na, kung sakaling ang pinili mong design process is ASD, determine muna natin yung PA, which is ang gagawin mo lang naman dito ay dead load and live load. PA equals PD plus PL. So, just take the sum. 750 kilonewton ang design process natin or ang design load. Then, next, ang gagawin nyo lang, yung tatlo, siguro i-flash ko na lang siya. Ito lang naman for R minimum, parehas lang daw siya ni LRFD. So, 15mm. Solve for the value of AG min. So, 1.67 times 750 times 10 cube divided by 290. So, napakalaki niya compared doon sa una, no? So, 4,318.97. And determine for the value of AE min. Note that the reduction or the safety factor is 2, that is 3,623.19. I believe nagagets naman na to kasi nga simpleng multiplication na lang naman. Ang sunod na gagawin nyo, balik ka doon sa table B6 ng Appendix B. Hanapin nyo yung mga section na may area na mas malaki dito. So, ito siya. Magsisimula tayo dito sa 4,740 kasi diba that is 4,318. Hindi naman pwede itong 3,920 kasi maliit yan, diba? So, yung top 5 natin, ito. So, 4,740, 4,740, 5,680, 5,680, 6,450. So, C250 by 37, C310 by 37, C250 by 45. So, increasing order. Okay? So, ito na siya. Yun na nga. Ito na yung area niya. Naisulat ko na. And again, itong mga values na to class, EW, X bar, and RY, hanapin nyo na lang siya isa-isa sa Appendix A. Okay? Basta kung gusto nyong mahanap yung arrangement ng section from largest to smallest, Appendix B. Pero kung gusto mong mahanap yung mga properties like yung area, moment of inertia, so on so forth, Appendix A ang gagamitin nyo. I believe you may check this, you may pause the video for a while, then hanapin nyo na lang yung nandoon sa inyong Appendix A. But feeling ko tama naman yon. So dahil doon, lahat ng R natin ay greater than 15. So safe na siya. Kasi 'di ba, yung R minimum nga is 15. Check nyo pa rin 'yon. So start na tayo, mag-trial and error. Ganon din lang naman ang gagawin natin diyan. Trial and error agad. So simulan natin kay C250 by 37. Ito yung una. So, yung area natin is 4,740 minus 2 times 20. Yung 13.4, yun yung thickness ng ating web, di ba? So, 4,024. Tapos, solve for the value of U. Only case 2 lang. So, yung U is 1 minus X bar over L. So, 1 minus 15.7 over 2 times 85. Ang U natin is 0.9076. So, yung AE is equal to ANU, which is 4204 times 0.9076. So, unang trial pa lang, swinerte na tayo na yung 3815.55 class is greater than the minimum net area. So, therefore, safe agad to. So, di ba? May chances na isang trial pa lang, yun na nga, safe na siya. So, swertehan din naman to minsan. Gayon man, I think na-conclude na natin na yung C250 by 37 is the safe section here. So, check nga natin ulit. Tingnan natin yung ano. So, 3623 kasi 0.19 yung ating minimum effective net. So, to conclude, tingnan natin yung sagot. Sa letter A, for LRFD, ang ating design section is C250 by 30. And for ASD, that is C250 by 37. So, kung titingnan nyo, katulad nung sinasabi ko kanina, usually, mas economical yung LRFD kaysa sa ASD. Okay? Kasi nga, yung LRFD is a new method. Yung ASD, matagal na to. Okay? Gayon man, decision pa rin naman to ng designer if he or she will use LRFD or ASD. So, I am giving you nga the choices naman kung ano ang pipiliin nyo dito. Okay? So, sige. I-end ko na itong video na to. And thank you so much for listening and watching. Bye-bye!